those things already left in good order. Forget.
All right. So I'm going to keep mine short, but I am going to cover a couple different topics here tonight.
So all the people are going to be 15, 20 minutes.
Sounds good.
Okay. All right. Me? Vegetarian. Me? Yeah. Okay. One each.
All right. So, thank everybody for coming out and making the best for us. So, one thing to start by saying, we're always looking for speakers. Not a headline for tonight, but I able to do it. But it was okay because I found a topic that I thought was great. That is artificial intelligence. So there's this Venn diagram here that machine learning and deep learning really just subsets inside of so what exactly is AI is defined as intelligence to learning and acting accordingly. There's been examples of this. I remember way back when in the 1980s, the video game and there's how the ghost acting their own AI and stuff like that. So they're just algorithms that we came up with that. But things have been getting more sophisticated here. And so machine learning.
Sorry to pause by the way. I'm ordering one veggie and one cheese medium. Is that going to be enough? If you're big eaters, I can get 2 meat. You think so? Yeah. Okay. All right. Sorry about that.
No problem. So machine learning is really defined as algorithms that work with data without really being programmed. And that's becoming part with a lot of the applications and stuff where it may not be practical for a human being to try to sit down and figure out all the different variations, but maybe some optimization and modeling where you can and deep learning is a subset of machine learning. The main difference here is that deep learning has become popular I think in the last decade because of computer, CPU and specifically GPU and CPU type of hardware, which really kind of accelerate and speed up these types of algorithms so they're very quickly on even inexpensive hardware. So deep learning is really a subset of that. Deep learning is being used for something like autonomous driving vehicles and other applications like that. But it really comes down to this. This is an example. And in this case, example here, the model takes these inputs and then it's going to determine an output. And in this case, with the neural network, you can have, and with deep learning, you can have multiple layers. And because of the CPU power now, it's actually becoming a lot easier to So what are some of the tools and languages that you use for doing this? Really popular ones are, most popular ones are Python. A lot of lower level stuff, you may have people that put class or Rust or something like that. But then, one of the things that they're doing now is that a lot of the library stuff that you use for machine learning that take advantage of the graphic processing on these computers. And the reason for that is because it's really good at doing this. And that's kind of the key to that, progression Google introduced a open source version of and there's also another popular project called Fair as well. And then also alternatives like Apple has something called FreeML, which will work also well for examples of this. So what are some real world examples of machine learning? Well, one that I thought was interesting was I had this sister anniversary of my fundraiser. Gentleman that was in charge of that project at Apple, talking about one of the problems they had in their and doing a stop keyboard smartphone, because they use touchscreen stuff like that. I saw a problem. Figure out it will show like the analysis here the options for the work. So that's one of the topics. Another one is you're using shopping on Amazon, for example. One thing Amazon will do is say, hey, do like this product or whatever, but it can't still apply like this product. It applies basically other examples are chatbot, whatnot. A lot of times it's not really being that's responding to the chat, it's actually responding to that. Echo voice control Alexa. It's actually using try to figure out exactly what question you're asking. You can ask the same question in multiple different ways. Figure out specifically what you mean when you're asking a question. Other examples are, image recognition. What's interesting is deep fake technology where they can take like a 6-meeting series and they'll put like a famous actor's face like on their page and they do like and then you self-driving cars more than I think they're trying to be the holy grail of AI computer vision self-driving cars. And then more recently, one that for a lot of people play with, which is GitHub Copilot. GitHub Copilot is the plugin for video I use for building. You can type in like a comment, and this is what I'm trying to do with this function, and it'll actually try to complete the function as best as it can. And that's based off of very sophisticated, very like that. I think Microsoft now is actually trying to start. So I installed it on my. I forget how much they're trying.
Yeah, that's one.
more traditional. And running that on Node.js, it actually does have a dependency on Python. The one I'm going to be demoing tonight is called natural.js, which is a natural language HTML library. I mentioned TensorFlow before, but there's a JavaScript called Node.js. You can actually run that in the browser as well. But we were running that in Node.
Question.
Yeah.
Are these things actually running within the browser, or are they accessing a service somewhere else?
You can actually run it in the browser.
No external dependencies.
That's correct, yeah.
Realize I'm on mute, so I apologize. All right. So anyways, so like I said before, many of these tools will run the browser without having an external dependency. The examples I'm showing tonight are not going to have a dependency on a service, but that's something to mention is that a lot of companies like Microsoft Azure, Google, for example, they all have these AI or machine learning, services that you can use. And one of the things that's interesting about the difference between Apple and Android is with the iPhone, for example, Apple tries to make as much of the machine learning stuff work on the device as possible, whereas on Android, they do have some things that you can do now on the device, but initially a lot of the AI and ML stuff that Google is doing require calls back to Google services. And so I haven't taken a look recently to see what the ratio is and stuff like that. Are there AI services? So with natural language processing, sometimes this is referred to as NLP. There's actually a company, a pretty cool company here in Jacksonville called NLP Logics, which is, that's their specialty, is doing applications around machine learning and artificial intelligence. And something else that you can also do with NLP is sentiment analysis, if I pronounce that correctly. And that's something that's also used because it's pretty popular, because when you're trying to take the tone, like the positivity or negativity of like somebody's comments and stuff like that, a lot of Wall Street companies, as an example, it's like they build these bots that go out and take a look at Reddit forums or Twitter and stuff like that to see what the sentiment is and stuff like that, and try to figure out, it's like, okay, are people really down on this stock, or are they up on this equity or something like that? And so that's one of the things that sentiment analysis is kind of good for. And then the example I'm going to be giving tonight is going to be on classification, where you want to take like an input and then declare like a classification. It's like, okay, what does this classify as?
Wait, is it what does it classify as, or does it classify in this class A, B, or C?
So I'm going to give you A, B, and C. So I'm going to give you the example of why I wound up trying to learn this stuff was because I'm sure we all get like these developer emails where you get like an email each week and there's like a bunch of articles in there. And some of them you find interesting, you want to read, some of them you don't. And so I'm like everybody else. It's like I spend way too much time just trying to go through and figure out which of these things I want to read and which ones I don't. It's just a waste of time, that kind of stuff. And so I figured, well, what if I could write a program that would go through these emails for me automatically, find the specific articles that I'm looking for, and then classify that for the specific topic I'm interested. So I'll give you a perfect example. So one of the things I do for this user group is I have a Twitter account. It's at JaxNode, and I retweet out any JavaScript articles or things that are related to the Node or JavaScript that I find interesting. So for instance, if I come here and I go to jaxnode.com, and I think, there we go. If you look over here on the right, you can see there's a Twitter feed right there. And over the last couple of weeks, nothing that's in this this Twitter feed has been stuff that I put in there. I've used this classification to try to figure out and do it. Now, it's not perfect because you can look through here, you can see that there's some stuff in here about Swift and Xcode, which is not, Node or JavaScript specific. So that's an example of why it's important that you train the model properly. So let me go back to my slides. So there's a general workflow that's usually used when you're using machine learning. One of them is, kind of creating a model for recognizing a pattern. So we talked a little bit before about, what some of the different types of models were. But the key here is you want to pick the best algorithm for creating the model that you're looking for. Then you have to create and find the training data, right? So we're going to train our model and basically what it needs to recognize. Then we're going to build the model from the inputs. And then once we've built the model from the inputs, we need to be able to test it for accuracy. And then once we've tested the model, know that the model's working correctly, then we can deploy the model. So for the examples I'm going to be giving tonight, I'm going to actually be just using the natural model. And there's a couple of things that the natural model can do. One of the things it can do is something called tokenizing. And that's basically, if you have, let's say, a sentence or a paragraph or whatever, it'll actually take that text and split it up into all the individual different words, and more specifically, like the important words. Something else that they do is something called stemming. And stemming is basically being able to detect the difference between words. So basically a new classifier that I'm going to use as the basis for my model. And then what I'm going to do is I'm going to come in here and I'm going to add documents to this classifier. So all these documents are really just strings. So the first one, I say my unit test has failed. I'm going to classify that as a software related document. The next one is tried the program, but it was buggy. Also, I'm going to declare that as software. And then the next sentence says the drive has a 2 terabyte capacity. We're going to classify that as hardware. And then the last one is I need a new power supply. That's also a hardware problem. So, and then once you've added these documents, then you can do the classifier.train, and that will essentially build out the model based off of the documents that you have.
Can you go back?
Sure. So the first parameter is basically the input, right? And then the second parameter is going to be what we want to classify it as, yes. So the classifications here are going to be software and hardware. Make sense? Yes. So the next one, so here for testing this, what I can do is I can just say classifier.classify, did this pass the test? Or the test pass, it's going to assume that's a software one. Did you buy a new drive? That's going to be a hardware file. So the next thing we need to do is once we've trained our model, we need to save it out. And with Natural, what it actually does is it actually saves out a JSON file with the metadata for the model. And so you can just use this JSON file as the basis for your model. And then what you can do is you can load that up. And once you've loaded that up, you can, in this case, I'm actually returning it back out through a promise. So whenever I want to go and use this specific model, I can just go here and call this method. It loads a classifier up, and then I just go in and start. I can start using it at that point. So
sausage. What do you have instead? Do you have any other meat?
So one of the other libraries is
One
Brain.js.
second, let me ask you. Instead of sausage, I ordered a half pepperoni and sausage mixed. They don't have sausage. What you can substitute for sausage?
Hamburger, ham.
Make it all double pepperoni.
That works.
Or beef. Yeah, make it beef actually. Pepperoni and beef. Beef is fine.
So Brain.js has a bunch of different algorithms that you can use for doing your modeling, and so one of them is the LTSM algorithm for classification. And Brain.js actually has the capability of using the GPU for doing this. But you can run it in the browser. But if you're running Node, it requires Python 2.7. So fortunately for us, this laptop that I'm running right now is Intel based. And one of the things I found interesting is if you're running like a newer Mac, so the last 2 years, Apple's been making Macs for a new processor called the M1. Now they have an M2 processor. And so Python was never originally developed to run on the M1 processor, which is really just an ARM64 based processor. So, but you can run Python 2.7 on it. It takes some trickery to get it working. There's a technology on the M1s called Rosetta, which essentially emulates an x86 or x86-64 processor. And so you can run it that way. So that's how I was able to actually get it running on my M1 Mac at home. For this one, I don't have that issue because you can run Python 2.7 on an Intel MacBook reasonably easily. And then TensorFlow.js, it also has a dependency on Python 2.7. But you can run in the browser, and there's other things that are really cool about it. Like you can use it for doing image classification, which is a pretty cool thing. You know, they use the acronym TFGS or TensorFlow.js, and they do support the GPU on M1 Macs. So, so if that's important to you, like actually being quick, the GPU is kind of important for a lot of these libraries and stuff out there.
But I mean, most of you're not going to run it on your laptop. It's going to be running
on a server. Yeah. So that's an interesting thing. So I was talking to one of the founders of NLP Logics, and he was talking to me about you know, their server setup. And I'm not sure if they're still doing this today, but a couple of years ago when he was describing to me, one of the things he was telling me is that, you know, they can't just put any old server into a server rack. They have to have one that has, you know, pretty beefy, like they're going out and buying these NVIDIA cards and putting them into the server. So essentially they're building out their own servers so they would have the hardware capacity they need to do.
Just for development, right? Do they still deploy it?
Because they will do a lot of, so a lot of this stuff is done in the cloud now. And so for instance, if you're using Azure or AWS or Google, for that example, they all have specialized hardware for doing this type of math. And so Google actually has, I think, their own processor that they call a TPU, or tensor processing unit. And I think all that is just a glorified GPU. I don't know, because I haven't seen specifically how it compares to a GPU, but Google's actually designed their own chips and using their chips in their data centers. So that, I think I'm ready to do the demo. And let's do this. Let's go into Jack's Node AI. All right. So I'm going to blow this up so we can actually read it. I am not using TypeScript, but I'm planning on learning. The company I just went to go work for, we use TypeScript there. So it's on my list of things to learn here. So what I did here in this example here, I set up a couple different examples here in this repo. I'll put the repo up on the site tonight. But in there, I have some examples of like actually how to do things like hamming as an example, how to do classification. This is a simple classification here using Brain.js. I'm not going to use Brain for my demos. So in this case, what I'm actually going to do is I'm actually going to use natural classify, this file that I wrote. And this has essentially, this is doing the same thing that we saw in our test, or sorry, in the slides before. So what I'm gonna go ahead and do is I'm gonna run this. And I believe I have this set up here under natural example. Okay, so it said the first one I thought was software and the second one was hardware, right? So if we go back and take a look at this again, the first one was, did the test pass? The second one was, did you buy a new drive? So I did a pretty good, that ran pretty quickly, and I did a pretty good job of classifying that stuff using this base classifier. So that's what I wound up using for my own stuff.
So it picks the keywords from there. Like I need a new power supply, so it sees that new is there, so new belongs to the hardware.
Exactly. So I'm going to show an example of specifically like how it actually compiles, because you can, when you save the model out, it'll save it out as a JSON file. So we'll take a look at the JSON file to see what.
The terminal window bigger, the hardware, it's in hardware, just a little.
Like right here?
Yeah. Software and hardware. Is it okay to add a couple more like random things?
Sure.
Audience requests?
Absolutely. Yeah. All right, what do we want to say here for this one?
Where's my floppy? Floppy disk, floppy.
Okay. And let's try running that again, see what happens. Kill that, and we'll run that again. Didn't pass that one.
But you can add. Let's add one to the training model, right?
Like a disk,
Sure.
Yeah, like no, keep this one and then add something to the training model, right? Something like that. Don't use the word floppy. Say
Where's
how
my
about
hard
flop?
disk?
No, just flop. I mean, something. I don't want to give it away, right? I want him to work for it.
Okay. So let's try running that again, see what happens.
It will work now.
And this is a giveaway.
This kind of is good.
Yeah, you can get rid of that word disk from it. Just flop.
Flop show. That's
Flop show. Yeah, flop show. Yeah, that's a good one.
Flop sure or flop
Flop
shirt?
show, and then show TV show. Yeah, let's see what happens.
All right.
And no, it's,
All right.
it's just a flop.
I'll give him that.
Yeah, but I mean, it is going to base the model off of like keywords and parts of keywords. So that's part of the stemming process, or more specifically the tokenization process, where it goes out and it basically it kind of breaks everything apart into like the base, the words, and it can actually break the words apart themselves to kind of figure out what exactly how is this being used.
So is this is a training a brand new model for your purposes only? It's not getting any other input. It's just using the algorithm or whatever that in order.
That's
to
correct.
create a
The
new-
only-
baby that was born on line
Yeah,
1
exactly.
or line 4, I guess.
Yeah. So-
and has
And
heard
you're-
5 sentences.
Yeah, and you're teaching it, okay.
in his
So
life.
the key to this, we've all heard the expression garbage in, garbage out. The key to this is the training data. The better the training data you have, the better your model is going to do. So with that,
Can we change one more request? Can we
Sure.
change in the test to the floppy test. Where is my floppy test?
Yeah,
In down there in the.
He wants to
in the-
change the.
oh, okay, let's see what it says. Yeah, where's my floppy
yeah,
test?
so,
Let's see the evidence software and hardware next.
yeah,
The
yeah.
test is in
A
the
little bit
software.
of both, huh? Being unfair to the child.
That's- Yeah.
Okay.
Let's see.
Yeah, things it's.
Yeah.
Software, so it's
Yeah.
like a software.
Yep.
Yeah.
Software.
All right.
That's good.
So the next example I have here is, this is actually some of the real data that I use for training my model. And so what I did was I went through some of these. I'm sorry?
Does it provide a confidence level, like percentages or anything like that?
I believe it does.
Or-
So yeah, that's actually a little bit more common. So for instance, like with the neural networks as an example, a lot of times it'll score and come back with like like I think this is a 92% chance, or this is a 0.55 chance or something like that. It's generally it's a number, it's a floating number between 0 and 1. It's generally what you'll get back.
you can do that.
Yeah.
The API allows.
Exactly, yeah. So here, what I did was I have, I'm just going to go ahead and close this. So what I did is I just, every day I would get one of my emails with a bunch of different articles in it. And here you can see these are coming from Medium. And I have a bunch of articles in here. And so what I did is I went through here and I either assigned a Twitter user for Jack's Node or one for Polyglot Engineer. So they're either Polyglot Engine 1 or they're Jack's Node, right? And then what I did is right here, I came in here and I set this script up so that it would come through, read through that directory, look for any files that end with a .json, put those into a file list. And then what I'm going to do is I'm just going to read these files in, parse them, and add them to essentially just a giant array of all these different documents. And then what I'm going to do is I'm just going to come here. I'm going to add each document as a classifier. And for the classification, I'm just going to use the Twitter user. So it knows whether it's Jack's Node or it's Polyglot Engine 1. And then once I'm done, I'm going to train it and I'm going to save it out as this classifier.json. So what I'm going to do now is I'm going to come over here and I'm going to say, let's see here, natural train. Yeah. All right. And so we can see in here too that I have some tests I ran here at the end. So these tests here, I just came in here and I said, how to remove an element from an array by an ID in JavaScript, goodbye Node.js. And then there's a third one in here called why Elon Musk fired most of his long-term employees. I keep on seeing that headline for whatever reason. I'm not really sure why. But anyways, so I just put each one of these in here, put these in here as a test. And you can see the first two came back with Jack's Node, which is the result I wanted to have. And then the last one didn't come out with anything. So if there's nothing, then I don't bother posting it. So what I'm looking for is either one of those two classifications. If I don't get anything back, then I don't bother posting it. And that's how that works. Yes, let's take a look at that. So let's come over here. What I save that out as? I save that out as classifier.json. That should be at the root level. Yeah, here it is. So I'm going to,
It is ASCII values,
oh, sorry.
numbers,
Uh,
the characters.
I'm trying to format this. I missed it. All right.
Or you can use the command, I'm not sure about that.
But you're right. There we go.
So what are these numbers?
So I believe basically these all correspond. You can see this is actually a very large document here. So I believe all those numbers basically correspond to a specific word. So if we come down here, we can see here that it's gone through here and it's got these totals in here. And then it's come here and it's defined these docs. So it's got a label, it's got text.
Kind of like keyboard type thing.
Mhm. But you can see here that it's doing some of the stemming and stuff in here. So for instance here, now it could be some of the stuff got trimmed, but I believe they'll use like versions of words in here as well.
Having some sort of ranking structure too, in order to figure out, because I'm sure there's probably overlap in which it's like
Mhm.
certain words are reused and they're labeled as Jack's Node or something, and then those words are used something else, but it's from, it's kind of a different way. So it's probably gonna have a ranking structure for multiple matches.
I'm assuming what it's doing here is that each one of these labels in here is assigned to a specific number key at the beginning of the model. But to be honest with you, I figure this would be the neat thing about using a tool like this, is to let the magic kind of happen.
Yeah.
And because, yeah, the truth of the matter is that, you're getting into statistics and data science when you start getting into machine learning. And my sister and my dad are both mathematicians by training, and my dad's retired now. And my sister teaches math at a school, but she used to be a Java programmer. And it's not a very encouraging sign about Java programming. But
I was a Java programmer.
I know, so was I. But the thing that's interesting is that, I was telling both of them is that, there's a ton of really neat career opportunities working with this stuff. Like if you're a mathematician, especially if you're somebody that understands statistics and statistical modeling and stuff like that, that is the exact kind of, linear algebra. That's the exact kind of math that is used for doing this. So, like I said, I'm the dunce of the family. So it's like, I was like, whenever I see, like linear regression and stuff like that, it's like, well, I'm gonna have to go back to school and learn that stuff. But my sister and my dad, they both know that stuff. But anyways, so that's kind of what's happening underneath the hood, so to speak, for doing this stuff. And I think this is kind of cool that, you can open this up and take a look at it, see what exactly is in here. And that can probably, if you need to debug your model and stuff like that, that can be very, very helpful. So like I said, I have all this code up. It's all going to be up on the on our GitHub page, and also posted up on the meetup. But one thing I want to do here before we end the night is I want to talk about